Hello students, I myself Professor M. N. Jadhav from KK Polytechnic. We'll go a little bit introduction to DIAC. Now let us see what is DIAC. So DIAC, it is nothing but the two diodes. They are connected in antiparallel, and the word DIAC stands for diode for alternating current. Here this is the symbol for diode in which we are observing two diodes are connected in antiparallel. So one terminal we may say as anode 1 and the another as anode 2, or in some cases the terminals of DIAC, they are termed as MT1 and MT2. Now it should be noted that the DIAC can be either turned on and turned off by both polarities of the voltage. That is, the types of voltage are positive or negative voltage. They also still works when avalanche breakdown occurs. That means when we increase the voltage from anode 2 to anode 1, the device comes in conduction, or when we increase the voltage from anode 1 to anode 2, even though the device comes in conduction. That's why it is called as a bidirectional device, and this DIAC is a member of thyristor family. Now let us see the construction of DIAC. As we know that DIAC is a bidirectional device, this having 4 layers and 2 terminals, MT1 and MT2, or anode 1 and anode 2. The construction of this DIAC is same that of the transistors, but there are certain points that we have to consider here. This particular device, it don't have any base terminals. The 3 regions have almost the same layers of doping. And one more thing, that it gives symmetrical switching characteristics for either polarity of the voltage, that is maybe positive or negative. Here in this figure we are observing the terminals. If I say that the main terminal 1 MT1 is positive, then the current flows from MT1, layer N1, layer P1, layer N2, layer P2 and layer N3 to terminal MT1, which is negative. In another way, if we say that terminal MT2 is positive, at that time the current has to flow from terminal MT1, which is positive, then layer N3, layer P2, layer N2, then layer P1, then layer N1, and lastly the terminal MT1, which is having negative polarity. Now let us see the characteristics of DIAC. As we know that it is a bidirectional device. That means DIAC conducts in first quadrant as well as in third quadrants. And the device comes in conduction when either of the polarity is positive for that one. In short, we say that the device comes in conduction when there is avalanche breakdown is going to occur. Now let us see here. In this particulars, we can see in the first quadrant VB01, that indicates the positive breaker voltage, and after this breaker voltage there is sudden drop across the voltage between the DIAC or across the DIAC. Similarly, in the third region we are going to say that VB02, it is a negative breaker voltage of the DIAC. After this point, again there is a decrease in voltage across the DIAC. Before triggering the DIAC, we can say that, or before coming the DIAC in on state, we say that it remains in blocking state, and after, when it comes in conduction, that particular stage we have to say as a conduction state. Now let us see the applications of DIAC. The most important application, as it is a bidirectional device, it is used to trigger the DIAC. That is the first point. Then it can be used in the lamp dimmer circuits. It is used in heat control circuits where the AC supply is present. It is also used to control the speed of the universal motors, and the important, which we discuss, it is used to trigger the DIAC. There are some advantages for DIAC. Those are, it does not switch sharply to voltage conditions at low current level as done by the SCR of a DIAC. Second point is that it has low on-state voltage drop until its current falls below the holding current level. And the last one, the voltage drop decreases with increase in current. So these are some applications as well as the advantages of DIAC. Here we observe some circuits in which DIAC is used as a basic components, and this basic purpose for this DIAC, that is, it is used to trigger the TRIAC because the supply is AC. This application, we observe that it is a AC power control, and another circuit, that is light dimmer circuit, in which we can control the intensity of lamp or the earlier or delayed firing of the lamp. So this is the compiled observations of the DIAC circuits. We observe here the circuit or the construction of the DIAC, then the characteristics of the DIAC, and the physical component of the DIAC. Thank you.